Today we'll be learning about the new topic called Docker. So, Docker containers. So everyone knows about Docker already. I have worked on Docker.
Prag, your voice is not clear. I'm not sure whether it's only for me.
Yeah, your voice is not
Yeah,
much
just
audible.
okay, just a minute.
Yeah, it's good now.
Yeah, anyone already knows about Docker or what is your definition for Docker? Can anybody tell? Or would anybody would like to explain what is Docker?
Uh, I don't know exactly, but I can
Mm-hmm.
explain what I know. It's kind
Yeah.
of a container. Docker is kind of almost like a pod
Mm-hmm.
used to to deploy our applications in a microservices kind of environment,
Mm-hmm.
where no need of having an entire VM or thing. Instead of that, we can run on the um, uh, in the container.
Okay. Yeah,
So
you're all.
it shares the. I mean, the whole container it will share the same. I mean, services thing instead of having self-host containers and its own services.
Yeah. So you're almost right. We'll learn the same thing now. So this is one of the very famous image for Docker. So this whale-like ship represents a Docker, and it's carrying some containers. Okay, the ship is carrying containers, and what does that ship has? Ship is having various kinds of wooden blocks. Okay, and when we pack these wooden blocks, uh, and the container is moved from one place to another, the wooden blocks will not be changed or removed. Okay, they will remain intact. There won't be any changes. You just put this containers on a ship, sent from one place to another without any alteration. Okay, and when the the other side receives this container, it doesn't see any difference because the wooden blocks are intact. Okay, so the Docker also does the same thing. It will ship our source code in terms of application, some binaries, some libraries. Okay, and that container can be moved from one place to another. Okay, without any issue, and it will run properly. Okay, so we will learn more about it. So earlier means now we will see before DevOps we say that that particular application is working on my machine, and after DevOps after implementation of DevOps we will say that it's working on my container. So which problem the containerization solves? Okay, so for that we just need to go through one example in which we'll see what is dependency hell. Okay, suppose there is a developer who has written a code in Java. Okay, the application is running fine on his laptop. Okay, he gives that Java code to the operations guy, and the operation guy will use that source code of the Java language, and he will deploy it on the server so that everybody can access it. Okay, but the operation guy complains to the developer that it's not working, but the developer says that it's working on my laptop. Okay, or my development system. Why it's not working on your system? And they both continue arguing. The operation guy think that you have missed something. Okay, you didn't give me the proper steps to install it. So the developer goes to the operations guy system, or you can say on the server, and he sees that there is a dependency of that particular Java, that it should run on JDK version 17, and the JDK version on the operations guy system or a server is 16. Okay, so there is a dependency on the Java JDK version. So when the operations guy updates Java version from 16 to 17, it starts working. Okay, so how to solve this problem? Suppose we package so that the developer package that code, okay, the Java code along with the JDK dependencies or the libraries or any other dependent third-party libraries or utilities which are required to run the that particular software. Okay, he packages into an image and he gives that image to the developer, to the operations guy. Then the operations guy will just run that image. Okay, he doesn't have to worry about JDK installation or any third party dependency. Okay, and it will run properly on the production environment as well. Okay, so in Docker also, or in terms of containers also, we do the same thing. We package the application along with its dependencies or any other things which are required. Okay, and that package, so if you see, I said that this package, see this container will have the application code, the dependencies, the third party libraries, everything packed in this container. This container will be passed from one place to another, that is that image, and that image will run without any issue. So how to do that, we'll be seeing that. Okay, and there won't be any hardware compatibility issue because the containers will be running on a separate layer. Okay, what is the separate layer? It is the container runtime. What is container runtime? Docker is one of the container runtime, so there won't be any hardware compatibility issues as well, and it will also reduce the complexity of the deployment. uh, when there was no containers, okay, we had to take care of all the dependencies, okay, how to install it and all. But when we create the Docker container, in short the Docker image, okay, that image is used without any alteration, okay, on every system. Okay, just copy that image and run it where the Docker is running, and it will run without any issue. And there is also a resource separation. Suppose there is only a single OS, okay, we do not have containerization, then it will be very difficult to have different versions of Java or any other application as well. We cannot have Java version 16 and 17 at the same time on any VM. Okay, will if we need a 17 version, and if we already have a version 16 of Java, we'll need one more VM. Okay, but in terms of containers, on a same OS we'll have one more container for JDK 16 and 17. Both containers will run on the same OS. Okay, we'll go through it. So any application release process or SDLC lifecycle is explained here. So the company or a group of developers come up with some idea that we'll be launching, let's create some application. Okay, they gather the requirements, okay, for creating that application. They'll code it, they'll test it, and they'll build and package it, and that build and package, okay, is deployed. The complete package is deployed on the production servers. So the build and packaging part, this is what most of the times as a DevOps engineer we will be doing. Okay, so what are those stages and all, we'll learn that later. But this is what is important for us, the build and packaging. So also look about in detail the SDLC lifecycle. Let's see what is difference between waterfall, agile, and DevOps. So as we said initially, this is how the SDLC life cycle works. Okay, so whenever in a traditional or in the old way, even few people are following the same thing now as well. In waterfall model, what happens is we'll design a code. Okay, the design is created, then the coding is done, then the testing is done, and then the deployment is done. That is in the waterfall model. That is from one step to another, it will keeps on following. That's why it's called following. That's why it's called waterfall model. And suppose if there is a bug, okay, after deployment, there is a bug, the whole cycle repeats again from the scratch. Okay, so again, suppose this in waterfall model approach, the software was built in 8 months. Okay, and if they find after deployment any bug, okay, then they will have to repeat the whole process, and maybe instead of 8 months, it may take 5 to 6 months. But again, this process is long. So in DevOps, what they do is they will divide it into small iterations. Okay, and dividing anything into small iterations means doing same thing in small iteration is also possible due to agile methodology. Agile methodology is already there. Okay, when we combine this agile methodology of small iterations with some continuous deployment. Okay, so the word continuous is important. So instead of waterfall model in DevOps, what happens is after design and coding, it will be tested continuously. Okay, everything will be done continuously, continuous deployment, continuous testing, and continuous feedback will be provided to the developer. So instead of waiting for 8 months, the developer will be notified very soon that there is a bug. Okay, and it will be resolved quickly. So instead of 8 months, the process becomes very fast, and the software can be built within 2 3 months only. Okay, but this is also possible using agile methodology. So combination of agile and DevOps methodology, that is agile with the continuous deployment, gives the stability and the automated approach to the DevOps whole process. So this is also a very famous image that everything is done continuously in continuous way in a feedback life cycle. So before going deep into the architecture of Docker, let's learn what is OS, because OS plays an important role, especially the kernel, in designing the container. So we know that we cannot directly interact with the hardware of the hardware. In any OS is comprises of kernel, shell, some utilities, and we cannot directly interact with the hardware of the system. So via shell, okay, will communicate with the kernel, and kernel communicates with the hardware of the system. So normally what we have seen is there is a one OS, okay, and there will be one kernel. So let's differentiate how the bare metal virtual machine containers or functions are different. So suppose there is a hardware, the physical hardware. Okay, on that we'll have a single operating system with a single kernel. On that will run any language runtime. Okay, language runtime means if the application is in Java, the Java related runtime will be running. Then we can have a container over it, and we'll have a code on that code. On that container will be running the code, but in this case there is only a single operating system. Whereas in virtual machines there won't be a necessity for a hardware. We don't There will be a necessity for hardware, but we do not take care of the hardware. We'll directly get a VM. We can have multiple VMs and multiple operating systems and multiple applications with the code as well. Okay, but they will be on a separate VMs. Each VM will have each single kernel and single OS. Similarly, in bare metal, there will be on a single bare metal, there will be a single OS, okay, and single kernel. But whereas in terms of containers, okay, we don't even have to install OS and language runtime. There will directly install the container. So in containers, there will be a single OS, okay, but multiple containers are possible, so that we can run the code in isolation and without interfering with each other. Both the all the containers will run properly. And in terms of functions, we are not covering functions in this course, but in terms of functions, we don't even install the containers. Directly the code is run. So AWS Lambda, Azure functions, Google functions are some of the example. Just give your code to that system and it will run it. So let's divide again the VMs and containers, how the VMs and containers differ. Okay, So this is the approach which we use in the bare metal servers like hardware, physical hardware. There will be an operating system and applications. But in virtualize or VM, there will be a hypervisor. On the hypervisor, we'll be having virtual machines. Okay, each virtual machine have an operating system, and binaries and libraries will be installed, and we'll have applications. Whereas in terms of containers, there will be operating system will run a container runtime. Docker is one of the container runtime, and we'll have separate containers. So the container comprises of application, binaries and libraries, and any third party utilities which we need. Okay, and suppose this container has JDK 16, this can have JDK 17, and this can have any .NET application as well. So now single OS, a segregation is done, and all this thing will be on a single kernel itself. Okay, so it uses the base kernel, base OS kernel, all the containers. When we'll have the practical, we'll also see that. Okay, so let's go deep into the containers. So Linux containers are possible because of some of the features of Linux kernel. Okay, those features are chroot, namespaces, and control groups. Okay, due to these features of the kernel, it is possible to create the Linux containers. So in chroot, what happens is this is the kernel feature which doesn't allow us to see all the directories. Suppose we are provided a directory structure, then we cannot go beyond that. Okay, we are just limited to the particular directory structure. And suppose there are some PIDs for which we do not have access, then we cannot see other processes PIDs as well. And in control group, what happens is we cannot use the memory and CPU. Okay, beyond which we will be given some quota, and if we exceed that quota, we won't be provided the CPU and RAM. So more details about it. So the containers are created based on the two main concepts of kernel, that is namespaces and C group. Okay, so what does the namespaces do? It control what a process can see, and C group control what a process can use. Okay, so this, due to this namespaces and C group feature of the kernel, it is possible to have the containers. And what are the features of container? They do not interfere with each other, and they remain in the isolation. So this is possible due to the namespaces and C groups. So let's go deep into the C groups. So C group, this is the Linux feature. It was invented by Google in 2006. Okay, and this feature of the Linux kernel helps us in isolation and control, means controlling the resources. The resource usage control and the isolation is possible due to this C groups. So what does the C group does? Okay, it will keep on checking if you are using a lot of processes. Okay, if you are using a lot of processes, then there will be out of memory. Okay, you will be giving a warning that you are out of memory. You won't be given memory beyond your quota. Okay, the same thing is done using C groups. And the first deployment of the kernel container was LXC. Okay, LXC is one of the containers which is available now as well. And Docker is not the only one containerization platform. There are some others as well. LXC is one of the first one. LXC was the first major implementation of containers which we see now. Okay, the same image, that container will have dependencies. So let's learn about some important concepts like container, containerization, Docker, and Docker engine. So we'll always come across some terms like what is container, what is containerization, Docker, how Docker and container are similar or different. Okay, so container, as we saw till now, is an application along with some dependencies. Okay. So whenever we say a container, it will always have some application running on it with some dependencies. Okay, which are required to run that application. And managing these containers, okay, is called as containerization. And sometimes we call Docker as a container, okay, but the Docker is a platform, or you can say it is a company which provides us the platform, okay, for building, running, and managing the containers. And how it does using internal component called Docker engine, okay, which helps us in the management of Docker. So Docker is so famous that instead of container, we call it a Docker. Just like the Xerox, we should call it as true copy, but we call it as a Xerox. The same way we should call it as a container, but we sometimes we call it as a Docker. And Docker is not the only container technology available. There are many others. One of them is Rocket by CoreOS OS, LMCT5 by the Google. But Docker has become the industry standard for containerization. Okay, and it is built on C groups and namespaces provided by the Linux kernel. Okay, and nowadays it is also available on the Windows as well.
Yeah, Azure Container Registry is something similar to this one.
See, container is different and container registry is different. About container registry, we'll be learning, but in short, I will say that wherever we store the container images, that place is called Azure Container Registry.
Okay.
And this will be seen later. Okay, so there, let's go here. So what are the alternatives for Docker? So Alexi, which is one of the first providers for containers. Then on Windows also it is possible to have Docker. Then Rocket, okay, RKT. Then Podman, this is famous nowadays. Podman, Runcy, and Containerd. These are very famous. And nowadays many systems, when we learn about Kubernetes, earlier the Kubernetes used to come with Docker, okay, but nowadays it is coming with Containerd, Runcy, either one of them. So these are also some alternatives to Docker. So Docker is not the only one which is in the market. And it is also important, or it's very interesting to see how the containers evolved. Okay, so it started with Alexi initial release in 2008, then OpenShift came, then Rocket, okay, then OpenShift Enterprise, and the Podman. So nowadays, if you install RHEL 8, by default, instead of Docker, they give us the Podman. Okay, so Podman is also similar to Docker, but a Docker requires root level privileges. Okay, which is not considered as very safe. Okay, and and it also runs as a daemon. Daemon means some process will be always running, requiring the root process, whereas in Podman that is not required. So sometimes you may also see in your company that they are using Podman. Okay, so but by default as well in the Red Hat 8, RHEL 8 onwards, and also 9, RHEL 8 and 9, the Podman is the default containerization platform which is used. Okay, now let's start the installation of the Docker. But before that, if you have any question, just let me know. Meanwhile, I'll just start my VM. Any question? Most, yeah.
Yeah. Can you just there was a one screen where you mentioned the bare metal container. So if we go with the real-time example, like Java example, right? Java application. So what all things are being, like when we are writing a code, I wanted to understand without container Docker and with container Docker, how it will be, how we can differentiate that.
Yeah. So whenever we write a code, okay, uh, like a developer will be writing a code, okay, and before that he knows, right, which libraries are required, okay, which on which version of that particular runtime it is running, okay, he knows all about it, right?
Mhm.
So he will be documenting that, And there is a concept of Docker file we'll be seeing next, okay, in 2-3 days. In Docker file, all those dependencies will be mentioned, and using Docker file we create our own image. So
Okay.
in that Docker file we have to mention all these things, what are the libraries which will be requiring and all.
Okay. So it has to taken care during the development or
Yes, development
oh,
process itself.
okay.
So there will be a difference in the development process. So the developer will not miss, he will also deploy it on his laptop without containers, but while deployment itself on the means on his laptop itself he'll run Docker container, okay, and he'll check if that the Docker container is running fine or not, okay, and if it is running fine he'll say use this Docker image which is also running on my laptop and just deploy it on your system. So in this case, that container registry will play an important role. So how he will give that image to him? He'll just upload it to the container registry, and from that container registry, that image can be downloaded by anyone.
Okay.
We'll be seeing
So
all
only
these things. So yeah,
okay. Sorry to bother you again.
yeah,
One
no
more.
problem.
So for example, I have a Java program, right? So my Java program is Hello World.
Mhm.
So the entire application is a Hello World application. So
Yes,
what we do, we code it and we deploy to Tomcat server or maybe WebLogic server, right?
yes,
So there are the DevOps team sitting, like DevOps or what we call the deployment team sitting, who will take a code from SVN. They will create a package using a ant script, and then they will deploy it to the Tomcat server or WebLogic server, right?
right. So in this case, what will happen is it will be a collaborative approach. Sometimes the developer writes Docker file, and nowadays most of the developers are writing their own Docker files, okay, and or they will take the help from the DevOps people, and they both will create a Docker file and they will test it on their system itself, and in Docker file itself they will be installing uh, means in Docker container itself it will be having a Tomcat server. So there is no need of installing Tomcat again. Just install that Tomcat in the Docker itself, Docker container itself, and give that container as it is for deployment on the server.
Okay.
So same thing we'll be doing maybe tomorrow. That we'll be having an Nginx. We are following the example of HTML app, and for HTML app there is a dependency that it should always run on some web server. So we'll create a container with that web server with our application code. Okay, so we don't have dependencies in HTML and all, but at least Nginx will be seeing in an example.
Okay. So this the Tomcat
Hmm.
Tomcat is now available. Like earlier, what happens? Like operating system in the operating system, we were installing Tomcat. So
Right,
now in the operating system, we'll be having container, and
right,
inside container there will be the Tomcat, right?
right, correct.
Okay.
So you can also have. So what is the approach? We are not so proficient in writing Docker files, and I don't know, and we don't know that how it will behave, right? So what we'll do is we'll have Tomcat on the VM as well for testing purpose. Then we'll note down those all the steps manually. First, this is the approach I also follow. First, install it manually on the VM. Okay, note down all the steps. Using those steps, create the Docker image or Docker container. Then test it, and then give that Docker image to the production for deployment.
Okay. Okay. Yeah, sounds good. And this you gave the example like Xerox and photocopy.
Yeah, yeah,
So
yeah.
Docker is a Xerox company, right?
Yes, correct.
And photocopy is nothing but the container.
Container, correct. And there are some other Xerox slash company that is
Podman.
Containerd, Podman, Runc, Rocket.
Okay.
Yeah. We
Sounds
are
good.
all aware about Docker only, right? Nobody till now was aware about some other container platforms.
Right.
Okay, so let's start our VM. The VM is ready. So today there is no homework or kind of an exercise for all of you. From tomorrow we'll do it together. Just go through the screen what I'm doing. But at least installation you can do along with me if your VMs are ready.
So will you be sharing the PPT?
As of today there is nothing to do, and you just go through this link. So whatever I shared in the PPT, almost 99% is available in this links. Okay, I didn't share today's link. This is the link.
Okay.
So if you want to go through the theory, you can follow this link. But tomorrow we'll be doing the exercise. Today we won't be able to complete it on the time. So I'll just tell you how to install Docker, and a simple Docker container will be installing. Okay, so that is the link. It also has all the details of the PPT. So let's install Docker. You can follow along with me. Sudo apt get update. For the first time we'll be doing the update, and after update we'll install Docker. Then just a simple command apt get install -y docker.io. Just don't install Docker. Okay, we need to install docker.io.
We will install Docker on Windows as well.
No, in this course, no. Everything on based on Linux.
Linux.
But in most of the production environment, it will be on Linux only. So
Yes.
only for testing purpose, you can have it on Windows. There is a Docker desktop, I think. Yeah.
What is docker.io?
This is just a package name to install Docker. Instead of Docker, they are saying install it as a docker.io. Generally, when we install Nginx or HTTPD or Apache, we just give the name as it is. But for installing Docker, they are saying just do docker.io. So after the installation, we can see where the Docker is installed. It is installed as a binary in USR bin. So the Docker is installed. Also check its version, Docker -- version. We have a version 24.0.5. So after installing docker.io, means the package name, we have Docker installed. Okay. So now I'll be creating some containers. Okay. So today you may not be able to follow along with me, but tomorrow we'll be doing this next exercise. It is similar to this one. Then you will follow. Then we will do it together. But today just see the concept. So we have installed the Docker now. We'll always use the Nginx and HTTPD as an example. Today also we'll do the same thing. So the first command after installing Docker, most of us the time we'll be seeing what are the containers running on it. Okay, so just to docker ps. So what does docker ps do? It will show the running containers. Okay, as of now we haven't installed any, deployed any container on this VM. Okay, so it is not showing any container. With ps-a we can see running and non-running containers both. Somebody is using keyboard, the voice is loud. If you can go on mute. So using docker ps we can see running containers. Using docker ps-a we can see running and non-running containers, and using docker images we can see any, if any image is downloaded on our VM or not. Okay, so let's start with the nginx container. Sudo docker pull, we'll start with the pull nginx. Okay, so what it is doing, let's see. So what it is doing is pulling the nginx image. Okay, now the question is from where it is pulling this nginx image. So by default it will start pulling the images from hub.docker.com, or sometimes I'll be calling it as docker hub. Okay, so docker has given a centralized, it is the container registry, this is the container registry, but available publicly. We can also have our private repositories here. Okay, so wherever we store docker images, that is called as docker repository as well, or docker registry. So here if we go to, if we check nginx, okay, somebody has already uploaded an image. The nginx company itself has uploaded an nginx image which was updated 8 hours ago. They keep on updating it. Okay, so we all so most probably it has downloaded it from here, because this is the only one. See, it is also giving how to download it. So by default it will download the image from docker hub. It is also possible to create our custom images and keep it on docker hub. Okay, we'll see that later, but now we have downloaded an existing image. And how to check if it has downloaded properly? Just to docker images. So when we do docker images, it is showing that the latest nginx image is downloaded on our laptop, and it is having a size of 187 MB. Okay, now we have just downloaded the docker image. We are not running it. Now we should also run it, right? So after pulling the image, okay, the next command to run the docker container is docker run. Okay, nginx, just press enter. Okay, so it started the container. Okay, but the screen is occupied, we cannot do anything on this screen. The process is running on this terminal, you can say. Now we'll have to go to one more, open one more session to that VM, and just do sudo docker ps. Okay, now you can see the container is running, the nginx container is running. It is running on port 80, but which port 80? Let me first check if port 80 is in use or not. We did some exercises last time. So first, you, if you are also using the same VM, then using this command systemctl disable nginx systemctl disable apache 2, because they will be occupying some ports which we'll be using in our next exercises. This is disabled at the time of boot of the VM. Now I'm also stopping the current session. Stop, and Nginx as well. This is important, otherwise we will not come to know from where the default page is served. And now if I check netstat, okay, there is no port 80 in use. This is something else. Okay. Now again I'll do sudo docker ps, the container we ran using command docker run command. Now just do docker ps, okay, and it's running on port 80, but is it running on the host? Let's check that. Curl localhost port 80, okay. It will say connection refuse. This is not running on the VM, I know that, okay. So why it's showing port 80? It's running inside the container, okay. Inside the container it is running on port 80. Now how to go inside the container? So the command would be sudo docker exec execute. Exec means execute hyphen it means an interactive terminal for this container id, okay, and then do bin bash. I'll attach to its bash shell, okay. Now we are inside the container, okay, and if we go do curl localhost, okay, port 80, we can see a default Nginx page is displayed inside the container. It is not yet available outside the container. And if you see, it has limited you can say system files, okay, whatever is required. So when we installed on our VM, at the time of installation it selects so many packages, okay, but inside the container it is having only the packages which are required for Nginx, okay, whatever required for Nginx, that is only available. So let's try to use telnet command. See, telnet command is not there, okay. If I do tab, it should show. Let's see vim, even vim is not there. Let's see, vi is also not there. So very limited commands will be available inside the container. We can install inside it any command using apt get install and all, but by default it will have very limited commands, okay. And this container is sharing the kernel of the VM, okay. I'll just go log out, just check. So inside the container, we are able to access the default web page. Just do docker ps, container is running. Okay. Now I want to access that container, that is the default web page on this VM as well. Okay. So for that, we'll have to do some port binding. Okay. We'll have to map the port of host means this VM to that of container. For that, we'll have to run the container with some different parameters or options. I'll just do control C. When I do control C, now it's not running. The docker container is not running. To cross check, just use docker ps command, and now it is not listing anything. But as I said earlier, using docker ps-a, we can see which containers are running and which are not running. So there was a container which is now in a stop state. It exited. Okay, it is now in a stop state. Now let's run the container again, okay, using docker run command. Docker run -d, okay. We are using -d because we do not want it to occupy the shell. So run it in a detached mode. So don't go with the word detach. It is detaching only from the shell, that is it is running in the background, okay. It won't show anything running on our bash shell. So we are using an option called -d to detach, okay. And then we have to use -p, that map port 8081, docker run -d, run in a detached mode and use -p to map 8081 port. We can use any port. For this example, I'm using 8081. Map port 8081 to port 80 for Nginx container. Okay, and I'll just press enter. But if I change this port 80 to 8081, it will not work. Okay, inside the container by default it will always run on port 80, and we should know on which port the particular service runs, and this we can change to anything. Okay, so I'm mapping port 8081 of this VM. Okay, this VM or this system on which we are running this command to port 80 inside the container. Now just do press enter. Okay, if I press enter, if you see, it is not occupying the shell now, and we cannot see anything now. It is running in the detached mode, means it is detached from the shell. Now I can use the same terminal, sudo docker ps, and if you see, it's available on 0.0.0, means on all the interfaces that container is available on port 8081. Now just do curl localhost, not on port 80 but 8081. Why? Because we have mapped port 8081, not any other port. So if you see, localhost will also work, the default Nginx page, then 127.0.0.1. okay, and it will also available on all the interfaces. So the IP of the VM is 192.168.1.11. okay, 1.11. okay, so it's also running on port 8081, and let's check it on the browser. 8081, it is also available. So this is the browser of my laptop, which is having a Windows OS, and that Windows OS is having an IP address 1.2. okay, so anything in the range of 192.168 1 dot something, it will work. So this is important. If the network is different, it is not available on the outside world because this is a private IP. If we have a public IP, then it will display to everyone on the internet. As of now, it is only available on my network. Okay, and just one more small example. So till now what I said, we just pull the image and then we are running it. Okay, but it is not always necessary to pull the image and then run it. When we run the command run, okay, docker run, it will automatically see if the image is available locally. If it is not available, it will run the docker pull command at the backend. We will even not come to know. So I'm just installing HTTPD along with Nginx. Nginx container is running. Now I'll be downloading an HTTPD image, okay, and I'll run it on port 8082 in a detached mode. Just press enter and watch the screen properly. It is unable to find locally HTTPD image, so it started downloading it. So we now onwards we will never use docker pull. Okay, we'll directly use docker run command. So docker run, we are running one more container that is for HTTPD, and mapped port 80 inside the HTTPD container to port 8082 on this host. Okay, remember we should know on which port HTTPD runs or any service which we are trying to deploy. Just do docker ps, and now I have two containers on it. One is running on port 8081 and other one is running on 8082, and both are not interfering with each other. Just do curl localhost 8082. okay, this is 8082 is for Apache, or you can say HTTPD, and 8081 for Nginx, and it is also available on the outside. Just to instead of 8081, just to 8082. Okay, it shows it works. This is serving from HTTPD. Similarly, I can install one more container, anything. MySQL. But for MySQL, we should know on which port it works. 3306, and I'll map it to port 8083 as well. This is just an example. I'll just cancel it. So I can have one more container. Similarly, we can have n number of containers, but remember it is using the resources of the VM on which it is running. Exact number I don't know, don't remember, but I'll let you know that there is a limit on number of containers which can be run. But it uses at the backend the resources of the VM itself. It shares the kernel. All the containers are sharing the resources of the VM. Okay, so we have these two containers running on it. And nowadays everyone is giving the installation. Suppose if they have a third party, suppose we want to download any ABC software or XYZ software, so nowadays they are also giving it as a Docker container. They are saying just download it from this Docker container and run using this command like this, and we don't have to follow any installation steps. It's just kind of a plug and play. Okay. So we'll continue with the new exercise.